Hey there and welcome. Today we're going to crack the code on a pretty common GCSE chemistry question, all about paper chromatography. We're not just going to find the right answer, we're going to look at exactly what the examiners are hoping to see. Using the official mark scheme, we're going to build that perfect 6-mark answer together, literally step by step.
So here's our game plan for this. First, we'll break down the main question to see what it's really asking. Then we'll get into the details and construct the answer for that big 6-marker. After that, we'll quickly tackle the 2 shorter questions before we wrap up with a look at the mark scheme itself. That way, you'll know the secret to grabbing every single mark.
Okay, first up, let's take a look at the challenge in front of us. We're going to focus entirely on question 03 from the AQA GCSE Chemistry paper.
So, here it is. This is the challenge. A 6-mark question that asks us to plan a full investigation to find the RF value of a dye. Now, I know it might look a little intimidating, but trust me, it's really just a sequence of logical steps. So let's get right into it and start building our perfect answer. Right, let's dive into the core of the problem. This is where we're going to see how to build a top-level answer for the main investigation. This is where most of the marks are, So getting this part right is absolutely key. Before we even think about the method, let's lock in our target. The great thing is, the question actually gives us the formula right there on the paper. Our whole plan is designed to find the 2 numbers we need to plug into this equation. The RF value, well, it's just the distance the dye spot travels divided by the distance the solvent travels. Simple as that. Okay, let's get into the setup. To get those top marks, you need a method that's so clear anyone could follow it. And the mark scheme is looking for these exact key steps, in order. First, and this is a classic mistake you've got to avoid, draw your start line in pencil. Why? Because ink would just dissolve and completely ruin the experiment. Next, you put a nice concentrated spot of your dye right on that line. And finally, you pour a shallow layer of solvent into your beaker and carefully place the paper inside. Now for the execution. Pay attention here, because these are the details that separate a 3-mark answer from a 6-mark one. You have to state that the pencil start line must be above the solvent level. A really critical and often forgotten step is to put a lid on the beaker. That stops the solvent from just evaporating away. You let it run until the solvent is almost at the top of the paper. Then you take it out and, this is vital, you immediately mark where the solvent got to, again with a pencil. Finally, you just let the paper dry. Every single one of these points is a potential mark, so don't leave any out. So, once the experiment is dry, your plan still isn't finished. You have to state exactly what you're going to measure. The mark scheme is super precise here. You need to say that you'll measure from the start line to the center of the spot. That's your distance moved by substance. Then you measure from that same start line all the way to the solvent front you marked earlier, and that's your distance moved by solvent. And here we are, the final step to lock in all 6 marks. See, it's not enough to just say you'll measure things. You have to close the loop. You must explicitly state that you will use those 2 measurements to calculate the RF value. This proves to the examiner that you didn't just memorize steps, you actually understand the whole point of the investigation. Excellent! We've totally nailed the 6-marker. Now let's tackle the first of the 2 quick-fire questions that come after it. So, the paper gives you this little scenario. 2 students use the same dye, but they get different RF values. It then asks you to tick the box that explains why. The options are usually something about the paper length, the time it took, the beaker size, or the solvent. So what do you think is going on here? The key here is just remembering what the RF value actually depends on. It's all about the interaction between the dye, the paper, and the solvent. So if the students use different solvents, they changed what we call the mobile phase. This changes how soluble the dye is and how far it can travel up the paper, which naturally leads to a different RF value. It's really the only one of those options that would cause this result. All right, let's move on to the final part of question 03. You'll see how this builds on our core knowledge of chromatography. This question is a straight-up knowledge check. In any kind of chromatography, you have a mobile phase, that's the bit that moves, and a stationary phase, the bit that doesn't. So the question is simply asking, what's the stationary phase in this specific experiment we just planned? And the answer is just one word: paper. That's it. In paper chromatography, the solvent is the mobile phase. It moves up the paper. The paper itself is the stationary phase. It stays still. It's one of those fundamental definitions you've just got to know. So, we've deconstructed the entire question. To finish up, let's pull everything together and summarize the key principles for earning maximum marks on this type of practical-based question. Right, let's boil all this down into a simple checklist for success. First, always write your method as a clear step-by-step sequence. Second, you have to be completely explicit about what you'll measure and from where. Third, always state that you'll use those measurements for the final calculation. Fourth, for those quick questions, you've just got to know your core definitions cold. And finally, use precise scientific language like solvent front and stationary phase. You follow that checklist, and you are set.
So there you have it. That was the blueprint for a perfect answer taken directly from the mark scheme. You literally have the formula for success. The only thing left to do is to apply it. So the real question is, what's your plan to practice this method on other questions? That's your next step.